I may not be able to keep this up for the entire week for this early, but but I wanted, especially for the first day, I wanted to be here for the plenary, get the feel for the direction of the group, things like that.
Excellent. So I think we're going to get rolling again, and Pierre-Antoine, I think you're up. So I'm going to pass this over to you, and take it away.
Thank you. So maybe I'll get ready to change slides. I've already introduced myself, so no need to do that again. I've been asked to talk about JSON LD and how it could be used as an alternative representation for DDI CDI, which gives us this not very original title, except for the fact maybe that I think it's the first title, presentation title that doesn't use any lowercase letter that I'm using, but anyway. Talking about JSON LD, we need to talk about RDF. I've been told from the discussions I gather that everyone here has some knowledge about what Rdf is, but a very short recall so that we're all on the same page. So Rdf is an abstract data model recommended by the W3C. In that model, information is broken down into statements of the form subject, predicate, objects. Hence, they're also being named triples. And every statement basically asserts that the entities represented by the subject and the objects are related by the relationship identified by the predicate. And a set of RDF triples or RDF statements is called an RDF graph because it can be graphically represented where subjects and objects become nodes of the graph and statements become edges. So what I just presented is actually one of the different specifications that make RDF and the RDF ecosystem. It's that one here, the Rdf Abstract Syntax, okay? And it's the cornerstone of everything else. All of the specifications rely directly or indirectly to that. We have the Rdf semantics, which allows to make automated reasoning, inferences based on RDF graphs. And on the other side of the abstract syntax, we have the concrete syntaxes or serialization syntaxes that allow us to represent those graphs into a set of a sequence of characters that we can store in a file or send over on the wire. And we have several of those concrete syntaxes. Historically, the first one, Rdf XML, is based on XML. We have text-based syntaxes such as turtle and triples. We have actually quite a lot of them, and the most recent, I think, is JSON LD, which is based on a very popular data format, JSON. So that's what we are talking about, okay? And given that, then to a short answer to the question at hand, how can we make a JSON LD representation of CDI? Well, first map CDI to RDF, as we also must discuss this week using Owl Shackle or whatever, and then for free. If you have an RDF graph representing your CDI data, then you can represent it in any of the concrete syntaxes, including JSON LD, and you have it. Problem solved, and I can stop my presentation right there. Except that there's a little more to it. And to understand that, let's take our simple example graph from the beginning and just straightforwardly serialize it to JSON LD. And this is what we get. And if you have ever worked with JSON before, then it would strike you that this, although technically it's valid JSON, okay? It complies with the JSON syntax, but it's quite unusual. It's really not like the kind of JSON that people knowing JSON are used to work for or to work with or to produce. It's quite inconvenient for some technical reasons that I won't delve into, but we can discuss about that. And all in all, it's really ugly, at least if, like me, you're a geek who ascribes some aesthetical value to computer code. If I gave this graph to a JSON person and asked them to encode this information in JSON, they would probably come up with something more like this, which is, well, first, much more concise, arguably readable even if you don't know much of JSON. And so wouldn't it be nice if JSON LD could actually produce that kind of JSON from the graph on the left and consume that kind of JSON to produce back the graph on the left? Well, the good news is it can, but it requires some extra work. Basically, JSON LD defines a number of, the specification, JSON LD defines a number of algorithms. We have 4 of them, there are actually a little more, but mainly 4 algorithms. From RDF, takes an abstract RDF graph and turns it into the ugly JSON document that I showed to you first, which is not called the ugly form, but the expanded form, okay? And 2RDF turns this expanded form into an RDF graph. This is basically what any concrete syntax provides, okay? But JSON LD doesn't stop there. We also have 2 more algorithms. Compact takes the expanded form and produces a compact form, which is basically, or at least can be, the second one that I showed to you. And expand does the opposite. Okay, so in several steps, we can indeed, from this graph, go to the nice compact document that I showed to you and back to the graph. But contrarily to those first 2 algorithms, those 2 algorithms need additional inputs. And let's try to see why. Let's go back to this example. Okay, objectively, there's less information in this document than in that document. Okay, and actually, this document on itself is rather ambiguous. It refers to a vague notion of person, okay, while in fact, this graph explicitly refers to a very precise notion of person, and we can see that in the expanded form, which is person as defined by the ontology schema.org, which, by the way, is defined as any living, dead, undead, or fictional person. Go figure. So, exactly. Or ghosts. So, okay, this is more pleasant to the eye. This is more convenient for JSON developers. But in order to accurately interpret this data, we need some background knowledge. We need some context to know that this, type or this relationship are the ones actually defined by schema.org. And in most cases, that background knowledge is available to developers or data scientists working with this kind of data. That's why usually we don't bother making all this contextual information explicit in the file, except that RDF is designed to provide interoperability across domains, across contexts. And so information in RDF has to be self-sufficient, has to be incredibly explicit. And that's why we end up with this kind of verbose and inconvenient data. So the special sauce, so to speak, of JSON LD is to make this contextual knowledge, this background knowledge, explicit in an additional file called the context, okay, which is also specified by the JSON LD standard, and which allows the compact algorithm to remove any information that can be found back in the context in order to produce the compact form, and to inject it back into the data when we expand it, so that then we can produce an RDF graph with it. Now, except for having nice-looking JSON files, what's the interest of that? Well, the interest is that all of a sudden, those RDF data are available to RDF people. We can use their RDF tools to tackle the graph, like Sparkle, OWL, and so on. But they also become available to JSON developers who don't know or don't want to know about RDF, and they can use just the compact form as they usually do. They can apply this background knowledge that they have implicitly without having to be bothered by the explicitation of that background knowledge. So the really nice thing that JSON LD has that other concrete syntax of RDF don't have is that it nicely separates the instance data, the interesting information in one part of the document, and the contextual information that most developers don't need anyway, at least on the left side, into a separate or relatively separate block, which is the context. Of course, we need to keep a link between the compact form and the context in order to keep the thing self-sufficient and to always be able to come back to the graph. So there are different ways we can keep that link. The easiest way is to put the context in the file, okay, but in a special attribute, of the JSON object called @context, okay, and that special attribute, JSON developers can just simply ignore it, okay, and that would give us something like that. So that's my compact form here, and just that attribute. So at first, it may look that we have a big file again, okay, but what's important is that all the contextual information is enclosed in a separate JSON object that, again, people can ignore because it's just in one single attribute. If it's too big and if you don't want to convey all the contextual information in every JSON LD document, an option is to replace that with a URL, okay, that dereferences to the context data. It has some advantages and some disadvantages, but that's also an option. If changing the data, if adding an attribute, even just for a URL, is not an option, then there's also a standard HTTP header to put this in the metadata that is used to convey the JSON data. So as a third option, you can just keep your JSON LD document like that and have the context linked to by HTTP headers. Or of course, you can also do this off-band, although that's more brittle if you change protocol or things like that. So what's in that context, okay? The primary role of the context is to map the short names used in the JSON, like person, works for, and so on, to unambiguous IRIs, identifiers, IRIs or URLs, okay, and depending where you come from. So those unambiguous names that relate to the concepts. So here, some of them also map to special JSON LD keywords, okay, but mostly here we say that person corresponds to schema.org/person, name corresponds to schema.org/name. I'm using a single ontology here, but of course I could mix and match different. I could map those things to terms coming from different ontologies as well. That wouldn't make any difference to JSON LD. But we can do many other things in a context. I'm just summarizing here, okay, because I don't have time to go into the details, but we can define prefixes so that we can abbreviate IRIs in the usual RDF way, prefix, colon, suffix. We can also disambiguate not only the property names, but the property values, because mostly properties in JSON have valued strings, sometimes numbers and booleans or others, and those strings can actually represent many different things. Is this string a literal, just the string value, or an IRI, the identifier of another entity? If it's a literal, is it really a string, or is it a date, or something else? If it's a string, maybe it has a language. We talked about the problem of languages earlier. Often they are implicit, okay, defined by the context. In order to convert this to RDF, we need to make this explicit. And so this implicit information can be encoded in the JSON LD context. If we have arrays of value in JSON, sometimes the order is relevant, sometimes it's not, and that's not encoded identically in RDF, depending on the significance of the order. So all these things can be, and others can be made explicit in the JSON LD context. JSON LD is made of three recommendations. The first one here, describe all this in a not too technical way. Hopefully, the idea of this spec was to be usable as an introductory material to JSON LD. It's not just dry, specky text. There's a lot of examples and a lot of rationale So it was really designed to make it as a good entry point to JSON LD. Now, an important point, what's not in a context? It may seem from this description that contexts are, and they are, okay, a way to transform a JSON LD document into an RDF graph. But JSON LD is not a general purpose transformation language, okay? You cannot, with a JSON LD context, take any JSON document that you could imagine to turn it into any RDF graph that you could imagine, okay? It's a specialized language. It's very opinionated. It favors simplicity over expressivity. Actually, some people would argue that it's already quite complex. But so the idea is not to make everything possible, but mostly what would be useful. I don't think I used the word idiomatic when I presented the compact form, but that's a word that I usually use to describe that kind of JSON. That's the kind of JSON that JSON users are commonly using, okay? And the idea is really to focus on idiomatic JSON and to turn it into their straightforward meaning in RDF. So it's not a general purpose language, and that will be important. So now we can answer our initial question with a little more nuance. What do we need to make a JSON LD representation of DDI CDI? Well, we still need an RDF mapping, okay? That doesn't change. But we can, in parallel to that, design a JSON format for CDI, okay? And when we have both, then we can start designing a context, a JSON LD context that does the mapping between the two. Now, there's a caveat here, because as I said, contexts are not a general purpose transformation language. And if we're not careful enough, then we might end up with problem. We might need some adjustments. I don't think there's a high risk here, because there's already a lot of work on having this conceptualization clear in UML. We already have an XML representation. So the risk of diverging to a point that context could not be used, I think, is relatively low. But in order to prevent that, probably the best solution is to do that in an iterative manner. That is, start working on an RDF mapping, start working on a JSON format, and early in the process, try to see if a context could be built to do the mapping, and change direction a little if that doesn't work out. A last thing that I wanted to mention, and it's funny because it resonates with the discussion we had during the break. There's another effort in which I'm involved that has been going on for a year or so around Rdf star. Rdf star is a community effort. It's not a standard, okay? But the goal is to extend Rdf with the ability to make statements about statements. That is, in this example, the new thing is this edge. And what's new is that this edge is not coming from a node, but from another edge. It could also point to another edge, for that matter. Okay, and the idea here is to represent the fact that this person is working for this organization. That's one statement. But they're working for that organization since a given date. And that's a statement about another statement. Sorry? Yeah, that's metadata. That's metadata, definitely. And that's really one of the goals of Rdf star is to bridge the gap between flat graphs in Rdf and property graphs who natively support properties on edges, okay? And so it's not a standard, but it's stable enough. There are a number of implementations already. Apache Gina is supporting it, but also commercial vendors have their own implementation of Rdf star and are involved in those discussions. So there's a strong push to bring this to standard track at W3C, and that's our plan for the weeks and months to come. And Greg Kellogg and I have been working on an extension of JSON LD in order to support that. So again, that's not standard, that can still move, but at the moment, and well, for this one, I think we have one implementation by Greg Kellogg that supports it, but the new thing here is that, okay? So this keyword could be alias, just like any other one, and here the works for statement is annotated by another statement that says that it's valid from that date. So, okay, it's not a standard, but it's moving quite fast, and I think as we are at building something new, maybe it's worth considering integrating those kind of evolution, and as they might find their way into the standard, and they might have great value for what we're trying to do here. And that's it. Thank you. If you have any question. Yeah.
With RDF star, is that recursive? So can you have a statement on a statement on a statement? Yeah. Okay.
So yes, it's recursive, and which also raises some eyebrows in some implementers, but the definition is totally recursive. So in theory, that's possible. Yeah. Oh yeah, it's turtle over again. That's what you said.
Akim's not here. I think he would be happy with this proposal. Maybe I'm wrong, and he'll tell you if I'm wrong. I think this idea of doing the sort of two-step, that makes a lot of sense to me, to have the compact. But are those algorithms on that side, the compact and expand algorithms that you mentioned, are those always the same? I mean, is that done the same way to every expanded form of JSON LD? You say it's an algorithm. Is that something that would be specific to the content in the model that you're expressing?
If I get your question correctly, yes, the algorithm is always the same. What really makes the difference is the definition of the context. So the context is very declarative, but it has a large impact on how this thing is compacted into that thing. And actually, you can, with different contexts, you can take the same expanded form and compact it to very different looking compact forms. And that's something that I don't think has been much explored, but that's also, I think, a very interesting way of doing data translation, possibly from one specific format to another.
There's a reason I ask, which is that we do not expect the different communities to necessarily bind the model the same way. They're going to optimize for whatever they're doing, and I think we recognize that's going to happen. This begins to give us an idea of how we might address that. So I like your answer. Very good. We'll see what Akeem thinks.
Yeah. Okay.